Okay, in this section, we're going to talk about the counting formulas. There's three important counting formulas we're going to talk about. The first one is the multiplication rule. This is where we just multiply the number of outcomes possible for each series of events. So let's say I talk to my husband and I tell him, I have lots of different meals I could offer you tonight. So let's say my main dish options are mac and cheese, pizza, meatloaf, or steak. Fancy dinners, right? Or my sides are applesauce, pears, or peas. My desserts are ice cream or jello. So if I want to say how many different meal combinations could I have, basically the multiplication rule just tells me I multiply the number of possible outcomes. So here for the main dish, I have 4 possible outcomes. Then I multiply that by the number of possible outcomes for the side dish, 3 possible outcomes. And then I multiply by the number of possible outcomes for desserts, 2. So I have a total of 4 times 3 is 12 times 2. So I have 24 different meal combinations I could offer my husband. Okay, let's look at permutations and combinations. So for permutations, order is important. For combinations, order is not important. Okay? So permutations, order is important. Combinations, order is not important. So for permutations, let's say 10 students go out and run a race. And if first prize obviously is going to be something like a big Reese cup, and second prize is only a piece of paper or something, and third prize is a pen, you're going to try harder if you really want that first prize. So if you have 10 students that go out and race, and let's say John really wants the first one, and he comes in first, and Betty comes in second, and Joe comes in third. That's one possible way of getting first, second, and third. Well, let's say if Joe comes in first, John comes in second, and Betty comes in third. Even though it's the same 3 people, it's a different order, right? So that would count as a second possible way they can come in first, second, and third. So that's why the order matters. So for a permutation, we take n as our sample size. So we have 10. We calculate our permutation. And because on this one it's first, second, and third prize, there's 3. Our R is equal to 3. Again, n is your sample size and R is your how many you're trying to choose. Okay? So in this formula, we use what are called factorials. So we use n factorial divided by n minus r factorial. So n minus r is 10 minus 3 factorial. Or we have 10 factorial over 7 factorial. So now you might be saying, okay, I have no idea what a factorial is. A factorial is where we take the number and we multiply it by every integer down to 1. So in this case, it would be 10 times 9 times 8 times 7, times 6 times 5 times 4 times 3 times 2 times 1. So 7 factorial would be, you got it, 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so you'll notice these cancel, right? So I'm left with 10 times 9 times 8, which is 720. Okay? Now, there's an easy way to do this on our calculator. Let me move my calculator over here. Okay. Remember I told you my favorite button is stat. So my second favorite button is math. Let me turn it on here. Oops, sorry about that. So math is my favorite button. Now you're going to arrow over to PRB right here. And do you see you have this NPR and NCR? So we want the permutation NPR. Now, before we choose that one, if you click down on it, you'll see it just puts it in. But what we have to do is we put our n in first. So you want to type in your n first, so our 10. Again, go to math, over to PRB, and down to number 2, NPR. And then the R we wanted was 3. Hit enter, and look at that. You get your 720. Okay? So, you know, do you really need this complicated formula? I'm not going to ask you to show the formula out. You can use your calculator to get that. Now, if the question asks you, what's the probability that John, Betty, and Joe, John comes in first, Betty comes in second, and Joe comes in third, our probability of that happening, John in first, be very specific, then Betty, and then Joe. In that order, there's only one way out of 720 possibilities. Does that make sense? Okay, now combinations, the order doesn't matter. So let's say I asked John, Betty, and Joe, 3 students, to help me carry books. It doesn't matter if I ask John first or Joe first. It's the same group. You only count that once. So you can see combinations would be smaller than permutations. So let's say I have 10 students and I ask 3 of them to help me carry books. This would be 10 combination 3. So you can see the formula is just slightly different, but let's go ahead and put it in our calculator. We put in 10, go to math, over to PRB, down to NCR, and then put in our 3, and there's 120 different combinations. So again, if it asks you a probability and there's only one case, you'd be 1 out of that. Make sense?